All right, we look to be at the 20-minute mark to go ahead and get started. I'm seeing people start to trickle in. It's always funny to like shame the people when conferences are IRL and they're like trying to creep in the back door, but if the speaker calls them out, they're like, "Oh no, I see you, I see you." It's one of the forms of entertainment that I miss is getting to interact with the audience. So as far as the way that you and I can communicate in this talk, you've got a couple different options. Obviously, you're probably in the Slack for NDC, so feel free to drop stuff in the Track 2 channel. I'll keep an eye on the chat tool inside this like Citrix session as well. But let's be real, Slack is way more fun, more emojis, more reaction GIFs. So do whatever you want. You can ask questions as we go. I'll try and save time for Q&A at the end. And we'll just have some fun in this remote environment. So if you have been to NDC before, welcome back. I'm sorry that we can't hang out in person. Very, very depressing. NDC is one of my favorite conferences just because the people are so amazing and it makes it really rewarding as a speaker. If you're new to NDC, you know, we'll be back someday, but you're really lucky. There are a lot of really talented, really brilliant speakers here, covering a lot of great content, but they're also very friendly people. They're, you know, just like you. So don't feel free to reach out, you know, ask questions. We love that kind of engagement. There aren't a lot of egos running around, so a speaker is not going to deem you as not worth their time, though some of us might be popping in and out of client meetings because we're not physically at a conference, and therefore it's sometimes hard to maintain those boundaries. Excuse me. All right. But what we're going to be talking about right now is reactive programming, state management, and Redux for the modern front-end developer. And I want to kind of put a disclaimer on this because one of the last times I gave this talk, I got feedback where somebody was very confused that this talk was not about React. Reactive programming is a programming style that is used across more places than React. I do Angular development for most of my day job, so a lot of these examples will be in Angular. But my hope is that we're going to talk about stuff at a really conceptual level. And so I would hope that regardless of what your framework of preference is, you'll be able to, you know, take some ideas away from this talk, have a better understanding of reactive programming, state management, and I'm going to talk about a really basic pattern called Redux that a lot of different approaches implement. And this might actually be something that you found yourself implementing before without realizing if you're trying to solve a lot of state management problems that we run into in the modern web development environment. So a little bit about me. My name is Jennifer Wadella. You can follow me on Twitter at OMG@Sveti. I'm the director of Angular development at a consulting firm called Bitobi. We specialize in front-end JavaScript development, but really all JavaScript. So we do Node, we do DevOps. We have a really talented UX team. So if you are ever in need of resources, be it training, be it staff augmentation or anything like that, my team can definitely help you out. I've got a bunch of great experts in Angular on my team that are really smart, awesome people that love to help and share knowledge. I'm an Angular Google developer expert, which is a program sanctioned by Google. Before pandemic, I would call myself an international speaker. Now I guess I'm just going to call myself a sit behind my desk speaker, a personal space invaded by cat speaker. I did really enjoy that, though. That brought me a lot of joy. And in normal times, I'm a kombucha brewing crazy plant lady. So if you're a kombucha fan, I want to hear about it. If you brew your own, I want to hear about it. Let me know, because I love talking about stuff like that. Okay, but when we get started, to talk about these concepts, we need to understand the reality of the world that we live in. And I know Dylan is probably here just because he wants to talk shit on JavaScript. What? I know, so surprised by that. But, you know, and I love JavaScript, but I am not somebody who's going to love something and not stand there and also criticize and point out flaws. Turns out we can do this for presidential figures too. Who knew? Anyway, but modern JavaScript development has grown rapidly, and sometimes it feels like, you know, we're a bunch of like really spastic Labrador retriever puppies, like chasing balls in all sorts of different directions without really understanding what might be the best direction to go in. We've come ways in building tools and libraries and frameworks to help us conquer a lot of patterns that we see in you know, modern application development and really finding better ways to do that. But there are a lot of problems that we've created for ourselves in the meantime. MVC was a really popular approach, especially when we were making that transition from, JavaScript being used to implement a jQuery slider to actually building functional single page applications. And this concept of a bidirectional data flow was introduced, made popularized, I think, a lot by AngularJS. This was their preferred approach. And it was really great for a lot of things. But that being said, when you're using this approach, you're very easily able to affect your application state in a bunch of different ways in a bunch of different places that can be really hard to track. And so I feel like that's something that we've been fighting for quite a long time, is writing better code that is less bug prone and just harder to figure out exactly what's going on, where our problems are coming from. In the front end, we're very much interested in the state of our UI, reflecting changes to the user, responding to interaction with the user. And so when you have all these different things going on, sometimes you'll have these undesirable side effects that can be really hard to track down. And so this is where reactive programming comes in. And if you're not familiar with this term, I'm going to spend some time breaking it down and talking about different approaches first, because I feel like this is something that it's a pattern that you have to get used to and have to really change your mental model of the way you're approaching programming, especially if you're used to the very common approach where I'll describe first. But this is kind of what we're going to be going toward throughout this presentation, is moving towards this idea of reactive programming, writing better code that is less side effect prone, that is easier to debug, and just more manageable, in my opinion. And so before we talk about that, I like to talk about imperative versus declarative programming. And whether you realize this or not, you likely are writing imperative code when you're writing in JavaScript. So an imperative approach is essentially some sort of event occurs, code runs, and changes the state of the program. And so before we get too far into this, I have a demo code base that I'm going to show you all. And so I'm going to be using this code base to kind of jump between these different styles, these different approaches, and use it as a demo, because I feel like sometimes it's just way easier to explain this concept kind of coding along. So let me show you my demo app. Quarantine life was hard, and Animal Crossing New Horizons was one of the things that kept me from going way off the depression cliff early on in Animal Crossing, and it stayed true. So there's actually an individual who has created a great Animal Crossing New Horizons API, and you can interact with it, get all sorts of information and fun stuff like that. So I have this silly little app that displays all of the villagers that are available in Animal Crossing New Horizon, and I have some filtering to interact with these villagers. So what this application is doing is it's making a request to a third-party API to fetch a list of villagers, and then from there, I want to be able to do all sorts of things to manipulate what is displaying to the user based on what they might be looking for. For instance, sometimes it's really hard to remember when your villagers' birthdays are, so you can make sure to get them a birthday present. So this allows you to sort by birthday, and you can see, whose birthday falls when, and you can kind of align with the calendar. You can also filter villagers by their kind of different attributes. So they all have different personalities. So we can look at just all the cranky villagers and see who all our cranky villagers are. We can filter by what type of animal they are. And this is just going to compound my filters. It's not like a true narrow down filter system. Where it'll include alligators that are whatever personality type. My WebEx thing is blocking my UI. And then I've got this little reset guy here that's going to clear all our different filters, get us back to, a blank slate. And then I've got some favoriting functionality here that will allow me to just show my favorite villagers. So that's kind of the context of the app. And I hope this feels like a common pattern to you, the idea that we have information that we're fetching from an endpoint. We want to display it in different ways and be able to manipulate it in all kinds of different things without doing something destructive or we're having to re-request information or anything like that. So that's a little bit of the context of our code base here. So when we talk about imperative approach, I'm going to kind of walk you through the code I have going on here and show you what we're talking about with an imperative approach. So the first thing that we want to do for this UI is we want to make a request to this, API. And so I have this masked into Angular service, which is going to make that request for me. Angular is built on top of RxJS, which we will cover shortly, because a good understanding of RxJS is one of our key tools in reactive programming in JavaScript. And so being aware of how that works is important. But for the sake of what we're talking about right now, I have a request that I'm making to an API that is going to return an observable. I'm going to subscribe to that observable, get the response. In my list component, I have an array where I am iterating over a list of displayed villagers, and that's how I'm displaying what you're seeing in the DOM. So this is something I care about. So what's happening here is I am, subscribing to this villagers function, and then when that response completes, I'm setting displayed villagers to be the value of that response. But if you look through this code base, anytime I want to do something to manipulate what is displaying in the UI, I'm going in and I am basically resetting the value of the displayed villager. So a user interacts with the application. A user decides to update the filter list of what they want. Okay, now I'm going through and imperatively changing my code to say, all right, now this has happened. I'm going to change the state of my application. In this case, the state is displayed villagers, and make that happen. And so the problem here is this can be really hard to track down. And especially when you're jumping into a code base, it's really, you're new to, you don't understand all the business logic behind. Who's ever experienced that before, right? It can be really hard to track down what's going on. And if displayed villager is being updated in a place that you're not aware of, this can be really, really difficult to deal with. So that's kind of what's going on with imperative programming. And again, I hope this feels very familiar to you because this is what a lot of us have been doing for years and years and years and years. All right. So when we talk about declarative coding or using a declarative approach, this is specifying how the state of a program should be altered. And so again, kind of an easy way to show you this is what I'll do to manipulate the code. But it's this idea of saying, hey, we know we care about this piece of state. These different conditions or things might happen to change that state, but we're going to let that kind of have an understanding or control of itself and be responsible for managing its state based on that, instead of us going through and manually changing the state in a bunch of different ways when a bunch of different things happen. So this example is a little RxJS dependent, but I hope it gets the point across to you. That what I want to do instead of essentially setting this every time to something different is I want to create a member on my class that is going to be displayed in the UI that is basically going to be aware of all the different situations that may affect it to cause something to happen. So what I would start doing is, I would kind of change my code here to say my displayed villagers is going to be equal to the response to this API service method. And a little bit about observables is you have to subscribe to get to your value, but we can do that in Angular using an async type in our template, so we don't have to worry about subscription management. So what I would do is I would start to set this equal to the value, but then I need to consider all sorts of other events that might be happening. For instance, like the filter list, if this changes, so what I'm going to be doing is I'm going to be combining different event streams and different responses from an API to make sure that my definition of displayed villagers is pulling all these pieces of information together. All I care about is making sure I'm handling the cases here, and then my UI will always be updated accordingly. Okay, so when we talk about reactive programming, then to bring this kind of full circle, it's a declarative programming style concerned with data streams and the propagation of change. Life in the front end, we're dealing a lot with user interaction and constantly responding and making changes to our code based on that. So it's this idea of propagation of change, whether it's like some sort of interaction with a click event or an input change or a form submission or something like that, and then integrating that with, interacting with an API, with dealing with data streams. So RxJS is a library for reactive programming using observables that makes it easier to compose asynchronous or callback-based code. If you are new to RxJS, would definitely encourage you to check it out. This is a library that everybody who starts using it understands the benefits, but understands it is a large learning curve. So this is not something to get discouraged by if you don't understand it right away. We kind of get forced into it in Angular because Angular is built on top of RxJS, which means a lot of the modules and services we're interacting with are going to be returning observables. So we have to have some level of baseline understanding. But I know it started to pick up steam in the React community as well. So definitely something worth checking out if it wasn't on your radar. I'm going to try and give you like the crux of the bare minimum of what you need to know, though, to get through this presentation. So we have observables, which I mentioned before, which are essentially a lazy push collection of values over time. So if we have a new observable that we're creating, the observer, or it has a next method, which is going to emit the new value. So then we are subscribing to our observable. Every time that next method emits a new value, we're going to get notified of that change. There are a lot of times in code that, like, if we're dealing with an endpoint, we just care about fetching it once a lot of times, right? So not a big deal there. But consider if a user is engaging with an input, we're going to want to get notified when that input changes. And so that's why RxJS can be a really powerful tool to help us handle really common front-end situations like that. All right. So a subject is a special type of observable that can be multicasted to many observers. A subject can be both published and subscribed to. So a lot of times what I will use subjects for is setting up events in my DOM. So if I want to know when a user has clicked on something, I might have a subject that, you know, emits a next event every time that user clicks with a value. And then this is something I can essentially merge into my stream that I might care about. So let's say we're doing filtering that's going to interact with an API. All right, I have my display villagers that I care about displaying. It's going to be based on the response of the API, but every time a click event fires, I want to merge that code, make a new response to the API with that new value. So those are some of the things that we can do with subjects. A behavior subject is very similar to a subject, but the key thing here is it will re-emit the last emitted value or a default value if there's a set. When we subscribe to observables, they're only going to get a new value after they've been created, which means if you have something that you care about, like let's say it's the state of an input, like an input text field, and you need to interact with the value that's there, and you have a subject hooked up to that that's emitting whatever the value is. If you subscribe after that value has been emitted already, you're not going to get anything with a regular subject. However, a behavior subject will get that last value that was emitted and allow you to use this. And so I feel like a lot of people get stuck on this, like not understanding you've got this other tool in your belt for handling a lot of situations. All right, then finally we have operators, and these are methods that we call on our observables to return a new observable. So really common use case here is we're getting data, we need to manipulate it in some sort of way to display it appropriately in our UI. Maybe it's, you know, we have an object that has a data prop, an error prop, something like that. All we care about is returning that data prop for the array of information. We can call an operator on that, like a map operator, return the value we want the observable, and do a lot of powerful things like that. We can merge streams. We can listen for different events happening at different times and make decisions based on that. All sorts of things. One thing I like to put on people's radar if they are new to RxJS, the Citrix bar is killing me. You're blocking my nav. One of the things you can do is if you go to the overview, they have this really cool operator decision tree. And so I feel like this is really helpful because there's so many different operators to learn to understand the different ways you want to manipulate your data. You can use this operator decision tree where you're doing some different things. So let's say I have some observables to combine together as one observable. I have a response from an API and I have a click event. Okay, let's proceed through here. And we can kind of step through and it'll point you to the observer or the operator that you should be using. So kind of cool little trick for you there if you are new and just trying to navigate your way. All right. So getting back to this idea of state management and what RxJS is doing for us, what we care about is making sure that we have control of when parts of our application state change, and we want to get notified of those changes. So consider a situation where maybe you have some sort of login methodology, and maybe you want to display that user profile in the nav bar, but in some component down your tree, you want to be setting flags for showing logic or displaying something based on a user's permissions. These are all sorts of things that we want to tie together and have this cohesive idea of a state that we can pull from, understand when those changes are made. And the important thing that we need to think about in state management, which I'll kind of talk through when we look at some of the library approaches to state management, is making sure that we're not causing side effects or adverse changes without realizing it. All right. So state management, defined as basically an organized approach to maintaining the state of your application. We want to do this in a way that we can read from it to update displays in our UI, but we also want to make sure that we're writing to our state in a manageable way. We don't want to be causing all sorts of changes that are really hard to track down. And so when we look at these state management libraries that are available, a lot of them are concerned with solving this problem. Is how do we keep the side effect or imperative behavior from happening and create a really cohesive approach. So we're going to talk through a couple things in this talk. We're going to talk about patterns and libraries. And so I'm going to start off by kind of talking through the Redux pattern, which, as I mentioned before, a lot of current state management libraries are built on. And I think if you kind of have an underlying concept of this conceptually, it makes it a lot easier for you to hop between different approaches and just figure out what's going on. And I'm also going to walk through basically home rolling your own solution inside of Angular just to show that this is something you can do. All of these things have pros and cons that I will talk through. So if we talk about Redux, this is a predictable state container for applications, credited by being created by Dan in 2015 at a conference. I don't remember which one it was, but this was kind of the introduction of the concept of Redux. So Redux 101, we've got a couple base concepts. One is we have a store. This is an object tree representing the state of your application. So in the state of this demo application that I have, we would have a couple different things. We would have our displayed list of villagers, would be part of our state. We might have our current selected filters as a part of our state. We might have available sort options as a part of our state. And the idea would be to update these and be able to read from these in a coherent and cohesive way. We have an action. And so this is an object describing how to modify the state. So example, we have this object tree representing the state of our application. And let's say we're considering our displayed villagers. And, starting off that, we're just going to have an empty array because we haven't done anything yet. An action would be us dispatching a request to an endpoint, for instance, to get the response of that endpoint and then telling the state, hey, I want you to update and add this to the state. So this displayed list of villagers becomes this response of this API. So we handle that by dispatching actions, which will say, hey, state, you need to do this. We have a reducer, and this is just a pure function that is going to take a previous state and return a new state based on the action provided. So a Redux demo code, if we were to kind of build this from scratch, like build our own version of Redux, we would start with something like this, where I have just an initial state where I'm going to be holding different information. So I care about villagers, I care about which sort option I have selected, I care about which filter options I have, and I care about whether show only favorites is selected or not. So here's where we're going to create the store. We're going to set our state for the purpose of this little app to be our initial state. And this create store is going to take a reducer. That reducer is our function that is going to take an action and then return a new state based on what that action is. And it's going to take our initial state. And then what we're going to be able to do is we're going to be able to access our store, get the current state, and then display it appropriately in the UI. So next we have actions. Actions are typically going to follow an interface that looks like something like this. We have the type, which is a string. This is how we're identifying our action. So maybe it's something like fetch API. And then we're going to have an optional payload. And this is if we are dealing with an action where we need to pass something to our reducer, that would be a part of the payload. So if we were to write out something like this, it might be making a fetch request to this API endpoint, and then calling this store dispatch method with this action. So it's saying, hey, action of type load villagers, payload is the response of this API call. And so then our reducer is going to say, hey, I received this action. I'm going to return a state based on what this action is telling me how to do. All right, and finally we have our reducer, and it's going to look something like this, where it's taking our application state and it's taking an action. And so typically you're going to see some sort of switch statement like this, where you are switching based on your type of action and kind of writing out for each of these things what exactly you want to have happen. So let's say in the case of load villagers, I'm returning a copy of the original state and I'm modifying the villagers prop on that state by passing it the payload of this action, and this action was that request to a third-party API. We've got a different one here where, okay, we've got this select sort where we want to track what our selected sort option is, again, passing some sort of payload there. And, you know, this is going to return our new modified state, and then our UI is going to get notified of that state change and reflect things appropriately. One other little tool I want to call out for you is there is something called Chrome Redux Dev Tools. And this is really, really powerful if you're new to state management to kind of track what's going on, or if you're jumping into somebody who has implemented a Redux-based state management pattern, you can jump through and see what's going on really easily. So I'll kind of, is this big enough to see for everybody? Yeah. Okay. All right, so we can kind of look through and see what's going on with our state here. Actually, let me switch to a state management branch. That would probably make more sense. For that to work. And we'll kind of poke around and see what's going on. Oh. Sorry, y'all. I know the golden rule is to not npm install between, but it's trying to branch hop to show y'all different things. But apparently the internet gods are humoring me today. All right. I'll wait on that to build for a second. And while I wait on that to build, we can talk about the first state management library that we're going to use. This is both beloved and hated by the Angular community. So I feel like it's 50-50 at this point, whether people prefer to adopt it or not. But it is a framework for building reactive applications in Angular, largely built on the Redux pattern. All right, now we've got my app compiled successfully. Do I need to enable something? I might need to enable something to show you all how this could work, but we can look at that in a minute. Oh, here we go. Oh, interesting. This will show you different tabs that you have open that have instances that can be selected. All sorts of fun stuff you can do here. Okay. So NGRX, pop up the documentation here. You're able to install this, and the first thing you're going to start installing with is the store. And this is very much the same concept of the store that I explained, talking about the Redux pattern, where it's going to be kind of like that place that holds your state that you can read from and dispatch changes to. So in our code here, for Angular, what we're doing here is we're initializing our store module, passing in our reducer, and that's kind of setting everything up. One of my preferred approaches to like implementing state management is I like to have like a really designated folder for this. If you are doing feature-based state management, where maybe you have like a larger application and you do need your state broken down into pieces based on what you're going to load in, absolutely fine to do that at a feature level. But this is a fairly basic app, so I'm just putting it kind of in line with everything else. And we can walk through what I have going on here. So let's start with my actions. And these are all the different actions that I have written that need to be dispatched to make the application change in the application state in the way we want. So the first thing we have is load villagers. So this is going to be an initial request to make that API call. One of the things that I really like about NGRX is what are called the effects. And these are basically ways to deal with all those weird situations where we want to dispatch an action and that action needs to do something and also return something that we then want to pass into our reducer. So we use effects to oftentimes interact with an API. So I have this load villagers effect that it's listening for this type of load villagers. Apologies, realizing not everybody might be in TypeScript land like I am. So here is, I am importing this villager's load string that is defined by my action. So essentially this is listening for that action to be dispensed when that action is dispensed. I'm making that request to my API call, and then I am taking the response of that API call, and then I'm calling this new action that I have defined here called villagers loaded. And so this is we've had a successful response from our API. I have data that I want to pass to my reducer to do something. So this villagers loaded action, the prop method defines the metadata, which is the villagers array that I am getting back from my data. So kind of event stream here is, all right, from my application at the point that I need data, I dispatch an action, okay? That action says, hey, go do this thing, go hit this API. So it calls the effect that hits the API, and then it calls another action that says, hey, I have the response, now go update the reducer. So if we look at our reducer, we have our create reducer function here. And this essentially is a mildly prettier looking switch statement under the hood. And so what it's doing is it's listening for all of our different actions, and then the action that we passed in, updating the state accordingly. So if we follow kind of this pattern through what's going on, now that I have my villager loaded action dispensed, my reducer is listening for that action. It's saying, hey, okay, you have a payload of villagers. I'm going to return this state with this villagers property set. And so that's kind of how we construct this. So this leads to some significant changes in the way we approach our UI. I kind of want to like have a branch open for y'all just for comparison so we can look back and forth, because I don't have a pretty enough diff tool. By the way, all of this is available in this repo that I have in the side links. These different approaches are in different branches. So if you're ever trying to implement, or you're like, oh crap, what was that one thing she was talking about? You can go and get that information here. But here's my main branch. This is just like a default. This is your straight up imperative approach to code. So I'm just going to pull up this file real quick so we can kind of look comparison wise of what's going on. So initially we had a lot of stuff going on in here where I was making this API request. I was setting the displayed villagers member on my component to the response to that list. I have this sort functionality where I'm doing all this logic to figure out like what that sort should be. I have my filter list where, again, I'm imperatively setting the value of displayed villagers to be like whatever the response of this filter function is based on some stuff I'm passing in. Same thing with favorites, where I'm displaying, displayed villagers based on some filtering logic and all sorts of stuff here. So quite a bit of code. And, you know, more often than not, we're going to be dealing with situations in our UI that we're going to be implementing similar patterns over and over and over again, and still need this idea of state management, this cohesive state where we want to apply changes to our code. And so this kind of thing can get messy really, really quickly. All right, so back to my code base. Sorry, this is just a helper function. What we're going to do to kind of initialize this application the way we want it is on our init function. This is the lifestyle hook for Angular. So when a component is loaded into the view and ready to do stuff, it is this function. We're going to go ahead. We're going to dispatch this action to our store, saying load villagers. Okay, so we dispatched our load villagers action. We'll go back and we'll trace this just to reiterate. Okay, this is what that action looks like. The effect that we've created is listening for this type of load villagers. When it gets that action, it is going to make a call to the API that we have written, and then it is going to dispatch a new action, villagers loaded. Our reducer is listening for this villagers loaded, and then it is returning a new version of our state with that villagers prop updated on it. Okay. So that's like the bootstrap of getting our component working in the way we intend. So the next thing we need to think about is, okay, so this has happened in our store, but how are we going to access it and display in our UI? So this is where we get into using what are called selectors. And so these are really nice utility functions that you have available in NGRX. And these essentially allow you to not only select a slice of state, but do whatever you want with the state. So a lot of times if you're displaying, maybe you're doing formatting of a list or something like that, where you're doing the same thing repeatedly, what you can do is you can write a selector that pulls that current state, applies whatever change you need, and that's what you're going to subscribe to in your UI. So here I've got my get displayed villager selector, and this is going to do a couple of different things. It's checking my state to see if I'm showing only favorites. If I am, I've got this villagers property on my state that's going to be the response of the API request. It's going to filter whatever's there and return only the favorites in that selection. Or the else statement right here is just looking, hey, is there a filtered list, and doing filtering based on what I have selected, and then returning that to me. So in Angular land, as I mentioned, we are very RxJS happy. So the store.select returns an observable. So I have that set as this displayed villagers member on my component. Again, if you're new, a lot of times we'll use a $sign after an observable just to tell the next developer down the line, hey, this is not just a straight value, you're dealing with an observable here. And then in our template, we are using the async pipe in Angular, which is essentially saying, hey, subscribe to this observable. Every time a value changes, update the UI accordingly. And the cool thing about this is we have component lifecycle hooks. And so in the onDestroy function, this observable will be unsubscribed from, so we don't create memory leaks. So that's like the magic going on there. Okay, so that's kind of the basics here. So setting everything up, we now have our initial display of all of our villagers. As we start interacting with things, we start to deal with different actions. So in this case, we have a filter list function that's being called anytime we apply our filter selection. So if I'm wanting to filter by different things and I hit this apply button, that's when that function is being executed. So there I'm dispatching a new action. This is a select filters action, and that action is expecting a payload of filter options, which is going to be an array of these different strings that can be there. So what happens is the select filters option is passed. We can go and look at our reducer, see exactly what's going on. Okay, select filters. All right, we're setting the filter options on our state and know what's going on there. Okay, so you can see how our code has gotten quite a bit more simple. We're not having to do as much management on our end with handling a lot of this, and these can be reused throughout our UI and throughout our application. So, definitely some benefits there to using a framework instead of kind of rolling your own approach and having to put it everywhere. Other things to know about, Angular does have its own built-in router, and so there are integrations for dealing with that router, because a lot of times what we're dealing with is caring about route changes. So for instance, in our application, if we click on a villager and we go to the route and the ID of the villager, we want to be able to make a GET request to our API to pull back the certain villager at this ID. So we are often dealing with subscribing to router changes and wanting to be aware of that. So that's something that NGRX has built in. There's also a component store, which is worth calling out. It's a standalone library for managing local component state. And so there are a lot of times that you are doing some heavy state management work, but it's really only to one component. And so it doesn't make sense to bring in all this full-blown stuff when you're just doing it at a component level. So they have the component store available. So a couple things that I do like a lot about NGRX is I really like the flow control. To me, like, I know the Redux pattern is a bit of a learning curve, and that really plays into onboarding with NGRX. But I feel like once you understand it, it's very, very clear where things should go, and you're not having to spend a lot of time thinking about how to solve what are in my opinion, common front-end problems when dealing with state management and making sure UI is updating accordingly. Selectors are a big deal. I like that a lot. Effects make it really nice dealing with API data, and we'll kind of look at other approaches and why they require a bit more handholding for that. And then the great thing about NGRX as well is built-in type safety. So if you are a JavaScript developer who's embraced TypeScript, it is nice to be working with libraries who have built that in mind and have a lot of great checks in place just by using their library that help you. Some of the cons, the API is fairly large and extensive. There's a lot to learn, and the docs aren't great. I'm not even sure what the current version is of everything. Like, for instance, you used to have to write a lot more boilerplate code just to create an action. This used to be a much longer thing. And I still like the docs are very scattered on what approach you should use and kind of laying things out. So a lot of times I end up pointing people to like some of the people maintaining NGRX and just saying, hey, go check out their Twitch streams, because sometimes it might be more helpful than the documentation. And it is a fairly intimidating learning curve. I think these are all valid concerns to call out based on your team and your capabilities. Obviously, I spend a lot of time in the consulting world, which means I'm bouncing around between different projects and different teams. And when you have a team that is, you know, just learning Angular for the first time and a lot of new concepts, sometimes something like this can be a bit too overbearing. But at the same time, if you know you're going to have a bunch of devs hopping in and out of a process and maybe they don't have the RxJS knowledge or understanding, sometimes using a framework like this that really has some nice like bumper guards for you can help eliminate a little bit of that chaos in your code base where people just don't know a technology well enough and then shoot themselves in the foot accidentally. So there's that. So Akita is the next framework that I am going to talk about. It's another state management pattern, also built on top of RxJS. A lot of very similar ideas here, but it is a little more lightweight. And so if you're like, oh, NGRX is just too much code bloat or it's too much big, Akita is a little bit thinner, but I feel like you do have to solve some of the problems on your own that NGRX offers you a pattern for solving. So if we check out our Akita demo, and do another npm install because I'm really tempting the fates today. I like to live on the edge. We can start looking through some of these files where we're going to have a very similar approach. It's going to feel somewhat like what we were doing for NGRX. And I will say this for Akita, they have a way cuter logo. Kudo Shiba. So docs here, we've got two basic concepts. Again, we have this idea of store. This is, you know, your Bible. This is the holy truth for the state of your application and how you're going to get information from your store. We're going to do something very similar where Akita has some built-in methods for us. So it's a little less action dispatchy, but kind of the same concept. We're going to say, hey, we want to do something to update our store. All right, so let's take a look at my store. Again, this should feel somewhat familiar where we have this initial state. We have our list of villagers, our selected sort options, filter options, favorites. The store extends this built-in class offered by Akita. And so these are where all these different methods are that they have provided for us for implementing. They've done a couple things for us. Like for instance, they have the set loading state, set has cache, get value, all sorts of things. So they've done a little bit of legwork of like different actions that you might commonly deal with, but most likely you'll end up using this update function a lot. So the problem here is you get a little bit less of a trace, because if you're just calling update with the state callback all the time, it can be sometimes harder to follow what you're trying to do and what modification came from where. So worth being aware of. Okay. Let's see here. The other thing we need to do is figure out how to wire this up. So let's kind of go through the same pattern again where, all right, we're starting off with our component. The first thing that we need to do is we need to get that request from our API. This is something that I'm not super in love with the approach that you have to take with Akita. So what I have done to kind of streamline this is I have my service. I have an API service. This is what we do in Angular, where we'll have a method, it'll interact with that, and we may have to map some stuff, we may have to not. This API is like goofy as shit, so I'm using this camel case function just to make my life easier. But I like to keep my API service files fairly clean. Like their only responsibility is fetching an API. So here I have built kind of a wrapper service, and what this is going to do is this is going to take my service. It's going to go ahead and it's going to make that request for me to the API. But then I'm going to call a tap function. And so this is like a side effect function in RxJS where it's saying, hey, I'm just going to pop in, I'm going to transform this as expected, but you can do something in this tap function. A lot of times we'll use it for console locking or something like that. So in this tap function, when this get villagers method has been called, I'm going to call this update method on the villager store that is made available to us by Akita, and then I'm going to update the state with this villager's response. So this I'm not in love with because it's like another extra step that you have to handle. You know, there's not a whole lot of type safety here and what's going on. But again, this is a good starter, like lightweight solution if you're trying to get the hang of things. So, all right, we've done that. This is something else that I have to do because this method is returning an observable. This is one way to handle it where I'm just going to take the first response because normally when I'm dealing with an API call, it's kind of, I just want to make that request once and then be done with it. So I'm using this take one operator that is essentially going to take the first one and then it's going to complete the observable so I don't have to worry about cleaning up my subscription. Okay, so that's going to help us populate our UI, but we need to get the information from our store. And so again, we're going to have some sort of like displayed villagers member on our component that we're indicating to developers behind us. It's an observable. And here we have this villager query that we're accessing in our component, and we're going to call this display villager. So if we look at our query, this is another piece of Akita. We're writing these queries that are doing something very similar to selector, where they're allowing us to select a slice of the state and then do something with it. So we can kind of look at what's going on here under the hood of this class that they're offering that we're extending. And they're, again, giving us a couple methods already available, like if we have some sort of loading state, something like that, all sorts of things. So just pretty easy to go and like, you know, dig through exactly what's going on without having to go update the docs. So this will allow us to select our state, return something on it. We can, you know, select pieces of our state, all sorts of different things. Okay, then the other thing that we have to do is, let's say we are, you know, we're filtering our list of villagers. How do we handle that in Akita? I've lost my file. Okay. Again, we have this update method that, you know, will allow us to pass in anything that we want to update on our store or our state object. So again, like we have this one method that kind of like does everything, but again, this can lead to making it a little bit harder to track down exactly what's going on or exactly why your state is being modified. But it is a really low learning curve, and especially if you are not a TypeScript guru, I feel like you might run into less typing roadblocks because you can do whatever you want, which again, you might shoot yourself in the foot with, but hey, at least your code will compile. So different approach there, maybe a little bit more easy to grasp. So with Akita, I do like the fact that it's a minimalistic API. Like you can jump into this, you can consume it fairly easily. I feel like it's an easier way to map out in your head when you're new to this approach. There is some built-in logic, like it's very bare minimum, like in not very robust or all promising. Like, hey, they just have like one loading state. So they're trying to help you out a little bit. And if you have some basic application logic or you don't need anything too hardcore, this would probably be a great use case. I really like the fact that you have to handle the subscription management on your own, which means you do need to have a somewhat decent understanding of RxJS. And it's also really not clear how to put logic. Like I use the tap operator just because a lot of times we'll use that in other state management approaches in Angular, but there's really just not a great way. So I tend to like guardrails, especially for when I'm going to clients that have really differing levels of knowledge, which is why I tend to go to a more framework locked in solution. If I'm working with a team of, you know, seasoned front-end developers who've been, you know, doing a hardcore front-end JavaScript development for like the last 10 years of their lives, it's going to be a different story then on the approaches we choose. So the last thing I want to cover is DIY state management with RxJS. This is kind of an approach that we take in Angular if we're wanting to do the minimum minimum, or a lot of times I'm on clients where they're like, ooh, boo, hiss, third-party libraries, and so you literally can't use any tools that might be more convenient for your use case. So we kind of call this approach simple state management with a behavior subject. And I will show you what that looks like. And we don't have to do any npm installs because we have not added any additional libraries to our code. So the first thing I'm going to do is I do like to create a store service that I can use throughout my application. So maybe I'm just dealing with this at component level. I can simply write a new class to manage my state for that component that extends the store. It's got some stuff on here now where I basically have a private state, which is a behavior subject that I can both publish to and subscribe to. And then we have our state, which is an observable, and this is what our components are going to read from our store. So we are going to initialize this behavior subject with our initial state. So like when we were creating that object that had like the empty villagers array and sort options and everything like that, we'll be injecting that here. And then we've got like a simple get method that is going to return to us the value of our current state. And then we also have a set state method that is going to allow us to dispatch the next or call the next method on our state behavior subject with a new version of the state. What this is doing and why we like this so much in Angular is this is helping us trigger change detection because it's passing an entirely new object as a state. And so a lot of times when you're dealing with, for instance, a nested array, you might not get the change detection trigger that you need because it's not considering that array changed if you modify it under the hood for us to update the UI in ways we would expect. Okay, so here's my basic store. I'm going to point out this is my service again. I am just interacting with my API, so I just have methods for that that's going to return the response in the way I want. So when I am writing my own state management approach, I might start with something like this, where I have my villager state. I know that this is just going to be dealing with my villager list component, and so I kind of want to handle all that. So I have my initial state, what that looks like. So here I'm extending that source service so I can use this throughout my application. I am calling super with my new initial state that I've created in here. And here I'm passing in my API service. And here I'm kind of writing my own methods to handle a lot of this. So similarly to NGRX, where we had that action that was dispatching the load villagers, I have a load villagers function that is going to interact with my API. It's going to take the first response. I mentioned that as kind of a way to deal with the handling subscriptions. And then in my tap function, so I'm taking the response of this request, I'm calling the set state method on my store class and updating the state or returning a copy of the state with the updated villagers prompt. So we're going to approach this very similarly in the way we consume it in our component here, where we are going to have to dispatch a call to load our villagers to kick things off. And so that's going to make the initial request to populate our state. And then as far as getting what we need from our state, this is where you do have to have a somewhat decent understanding of RxJS, because you're going to kind of be writing your own selectors almost here, where, okay, I want to get the list of displayed villagers. So I want to get my state, look at that object. I might have a function where I've written this on my state to update displayed villagers. So this is going to look at my current state. It's going to figure out, what the status of show state favorites is on my state. It's going to figure out the status of my filtered list, and then it's going to return to me my filtered villagers that I want to display. So have moved some of that logic and kind of written my own selectors here. But again, it's not very distinct what's going on. So it will get the job done, but it can be hard to read if somebody doesn't know, and you do have to manage a lot of this stuff on your own. Okay. So we can, when we start to interact further with the state that I've written, okay, we're just calling methods on our state to do different things, and then we're trusting that those methods that we have written on our class will be updating our state accordingly and not doing anything weird. So we are to the point where we can only interact with our state in this one very certain way. So we're cleaning that up a little bit, but this is not foolproof. And especially if you are dealing with managing subscriptions or things like that, this can get messy in a quick hurry. All right, so The big pros here are you don't have to install a library. There's no API to learn other than RxJS. But like when you start rolling things on your own this way, it can be easier to understand the whys of RxJS or state management or the approaches that different libraries have taken. Because, we all love to like write our own solution all the time. Nothing else matters. This is a really great way to get familiar and understand the different problems that state management libraries are solving or things that you might want to solve in a different way. Big cons are you have to do literally everything. So if you have a team that is less knowledgeable in RxJS, less knowledgeable in a lot of these concepts, it can be really, really hard to get everything on board. And again, you can really easily shoot yourself in the foot if you do not have a good RxJS understanding. So kind of big picture thoughts here are state management is good. Like we definitely, as much as we can, want to get away from this approach of imperative coding where we are constantly manipulating things based on state happening. We want to move towards, a declarative approach where we're saying, hey, this is something that we care about in our state. We can derive what should happen to this based on these different situations happening. And RxJS and reactive programming get us that much closer to that goal. It's perfectly fine to choose an approach that works for you or works for your team. You do not need to jump to the new shiny object of state management. It'll be more pragmatic if you understand the skill level of your team, understand the constraints that you're going to be working with. And overall, don't be scared of RxJS. I feel like it's still the library's been out for, I don't know, almost 10 years now, and it's still a very intimidating concept, but you're not going to leave the house anyway, so spend some time learning RxJS. I have my demo repo here, so if you want to kind of pick through this code, see the example, see how I wired things up, like I'm that person that I have to be like really hands-on and playing with things, you can get it available here. If you want the slides, they are available at statemanagement.jenniferwadella.com. And I think we have about 4 minutes left if anybody has questions, comments, concerns.
Thank you. That was awesome.
Glad to hear.
This is the silence you get at the end of a talk where you're like, either everyone has achieved complete enlightenment or nobody wants to be the first one to make a noise because they don't want to cause a fuss. So unmute yourselves, folks. Give us some give us some feedback. Give us a bit of noise. Doing this in silence is weird.
Well, it's also like it's hard for me to gauge too as I'm talking because like I know I've given talks at conferences before and I go into a little bit advanced and then just like the fear on people's faces and then I could be like, oh, okay, we're terrified. Let's back the train up and go into a little bit more in depth.
No, I was wondering, you showed an approach where you built it yourself. You've shown NGRX. I kind of like the NGRX thing because in the long run, that will give me a lot more. Is it a bad thing if I'm thinking, well, for my teams, I'm going to take it slow and basically force them onto the NGRX route? Or can you switch between the self-made thing and then upgrade to the tool?
You can definitely upgrade. And like the thing is like the shift from that imperative code approach to any sort of state management approach is going to get you over a huge hump. And so I actually was just like rewriting this presentation because I had it in this like other mono repo and I had like all sorts of other random stuff. And I was like, all right, people might get confused. So I like redid all of this in an hour this morning. And it was very easy for me to, once I had like one approach down, then you just kind of go change the things you need to add in the code there. So, yep.
Cool. Thanks.
Yes.
For the record, I think JavaScript is an awesome language. My biggest reservation is that when I use it, I have a lot of fun, and history has told me that if I enjoyed building something, it probably shouldn't be in production.
Word.
Personally, I feel that the whole approach with TypeScript and Angular is a lot better for larger teams and larger applications.
Yeah.
And I remember following a course in JavaScript, and they spent 1.5 days explaining the conversions between types. Not the types themselves, but the conversions. So we would understand what would happen if we misplaced a plus sign or anything of that nature.
Yeah. No, JavaScript is... Sorry, Jennifer, go on.
Oh, no, I was just going to say, like, I'm just coming off a code-based audit where, like, literally the first thing I was like, type all the things. And
yeah, exactly.
the cool thing is, like, you know, Angular 11 now basically puts you in strict mode on their recommendation. That's their default setting, which means you're going to have to type function parameters. You're going to have to type function returns, no implicit any. So it helps force you into doing things the right way, because a lot of people will just slap code out there and they just won't spend the time to learn TypeScript, and then they'll just like do whatever hacks they can. TSLin, ignore next line everywhere.
The one question that I have then is, so TypeScript allows you to skip the types where it's obvious, in the sense that the compiler knows how to resolve them. Is that still a thing with strict mode? Can I still skip the...
Yeah, so like, let's say in my, let's just say, like, you know, if I do this like this, that's enough for the compiler to know, hey, I'm going to go ahead and assert this as a Boolean. So, yeah.
Yeah, okay.